Have a nice day. In grade 7, lesson 5, we discuss about program development. The 5.1, we discuss about decomposing the problems. Yes, I have given the tutor. What is the primary intention of a computer? The answer should be the primary intention of a computer is to solve problems and make tasks more efficient. It's a kind of answer why we want computers. Mainly, primary intention of computer is to solve problems. You have used different kind of applications that can be Microsoft Word, PowerPoint, Excel, or Messenger, WhatsApp. Or these kind of applications, mainly software, are created for to solve any kind of problems that we to particular or specific problems they try to resolve. Okay. Then next one is, why is it important to decompose a complex problem into smaller subproblems before attempting to solve it? Yes. When we want to solve a problem, most of the time, it is very easy to, we can decompose the problem. The answer should be decomposing a complex problem into smaller subproblems makes it easier to understand and manage. By breaking the problem into smaller, more manageable parts, each subproblem can be analyzed and solved independently. So, when we want to give a solution for problem, we have to follow some steps. That's we call the algorithm. So, what is an algorithm? An algorithm is a set of step-by-step, well-defined procedure or set of rules used to solve a problem or perform a task. It is a fundamental concept in computer science and mathematics, often serving as the foundation for writing programs or performing calculations. So, in program development, this lessons we have to create algorithms. We have to display. We have to show algorithm by using flowcharts. So, next one is, why are algorithms important? Why are algorithms are important? First one, efficiency. Algorithms help solve problems in an optimal way, saving time and resources. The second one, clarity. They provide a clear and systematic approach to solving problems. Reusability. Once designed, algorithm can often be reused for similar tasks. Scalability. Efficient algorithm can handle larger or more complex problems. So, fifth one, what are the three type of control structures that an algorithm can include? The algorithm is a set of instructions, set of steps to follow a solve problem or task. So, these algorithms can be operated in three kind of control structures. If they are the three type of control structures that an algorithm can include are sequential control structure. The sequential control structure means instructions are executed one after another in a specific order. You should remember these control structures. There are three kind of control structures. When you in grade 8, 9 or in O-level examinations and also in A-level also, these three types of control structures are important. The same concept we are discussing. So I will repeat it. Sequential and control structure, instructions are executed one after another in a specific order. The second one is selection control structure. The second one is selection control structure. A decision-making process where specific instructions are executed based on a condition. It is called if-else statement. Depend on the conditions, other instructions execution process are different. Okay, I will repeat again. Selection control structure, a decision-making process where specific instructions are executed based on a condition. Based on a condition. The first one is sequential control structure. We cannot see a conditions. The third one, iteration control structure. Repeatedly execute a set of instructions until a condition is met. Loops like for or while. Okay, it's a kind of loop, continuously doing something until conditions become true or false. Okay, there is a conditions in both selection control structure and iteration control structure. Yes, we are going to discuss separately them in later. Why are control structures important in algorithms? Control structures are important in algorithms because they determine the flow of execution of instructions. They allow algorithms to handle decision making, execute tasks sequentially, and repeat actions as needed. This makes algorithms more dynamic, efficient, and capable of solving a variety of problems. Okay, I will repeat it again. Control structures are important in algorithms because they determine the flow of execution of instructions. They allow algorithms to handle decision making, execute tasks sequentially, and repeat actions as needed. This makes algorithms more dynamic, efficient, and capable of solving a variety of problems. The seventh one. Can an algorithm include more than one type of control structures? Yes, the answer is yes. An algorithm can include one or more control structures, combining sequential selection and iteration structures to solve a problem effectively. So, draw three types of flow chart for the three types of control structures. An algorithm, we should say someone, this is the flow of steps to follow this kind of problem. So that can be expressed in different way. In graphically, algorithm can be displayed using flowchart. The flowchart we use to demonstrate, to show an algorithm in graphical way. We can use uh, pseudocode, or we can use native language, or we can use active programming language code. It's a work in programming code, and other different way we can display. In simple way is it's very easy to understand other persons if we display flowchart as describing the algorithm. If I want to show an algorithm, it is very easy to understand when we show it that using the flowchart. So the control structures, three control structures we discussed. The first one is sequence, and second one is selection, and third one is iteration. For these blank spaces, it should be contained this flowchart. The first one sequence, the second one is selection, and the third one is repetitions. Sequence, the algorithm operate step by step. In selection, there is a conditions. The conditions display this kind of symbol. Okay, and repetitions, you can see the arrow go ahead again, go upward. It is kind of repetition. See, repeatedly do something until conditions true or false. Okay, selections depend on the conditions. The flow of steps will be different. But in sequence, we cannot see conditions. Okay, let's move to again the tute. Explain sequence control structure. Execution of instructions in algorithm sequentially from top to bottom. Top to the bottom is called sequence. Execution of instructions in an algorithm sequentially from top to the bottom is called sequence. The flow chart is this one, the sequence, top to bottom execution instructions, step by step, sequentially. What are the examples of for sequence control structure? Printing messages. If I want to display hello world, my name is a kind of sequence control structure. Performing arithmetic operations, calculate area, calculate perimeter, calculate to a summation of two numbers. Those are belong to sequence control structure. Reading input and processing. Temperature conversion. If I give the Fahrenheit, it can be converted to Celsius and otherwise Celsius to Fahrenheit. Make a kite is a kind of sequence steps. Cover in a textbook is a kind of sequence control structure. Finding the area and perimeter of a rectangle. Simple interest calculations. These are belongs to sequence control structure. So what is a flowchart? Yes, I expressed in previously also. Flowchart is a visual representation of a process, workflow, or system that use symbols, shapes, and arrows to show the sequence of steps or decision involved. An algorithm we can represent using visual graphics. It is called flowchart. A visual representation of process, workflow, or system that use symbols, shapes, and arrows to show the sequence of steps or decisions involved. What are the symbols we should use to draw flowchart? Mainly, we use these kind of these symbols. You should remember these. It is very important. Please make sure you are remember these icons. Mainly, start and end. This kind of rectangle we represent the process. And third one, we display input and output. And the fourth one is to display condition or selection. The last one we use arrow to display flow. The flow of the algorithm, flow of the steps, we use arrows. Again, the first symbol we use to start and display the start and end. The rectangle, the second one is used to process, and third one to display input or output. If I want to get something from a user as input, we use the third symbol. And if I want to create some conditions, as I mentioned in selection and repetition, we have to use fourth symbol. And always we have to use arrow keys to display the flow. So in next video, I will discuss the draw of flowchart for the selected scenarios. Go through this and your textbook and make sure concept is thoroughly understand. Okay, thank you.